So I'm going to talk to you a little bit about the 3 questions that Jason asked us to address in our slides. And again, I didn't necessarily stick to the 3-slide model, but I got pretty close, so we're just going to go with it. The first slide, he asked us to talk about what some of the biggest challenges that we face are in our perspective. And I function with a lot of tabs open in my brain all at once, and so I couldn't just pick one. So I have 3 here that I feel like are going to be really important to overcome moving forward. The first is breaking down generalizations. We see sound bites a lot in the media about beef and climate change. Things like, cattle are the largest land users, or it takes 10,000 liters of water to produce a steak, or grazing on public lands is ruining them. But we know that not all of those things are true, right? Those things are lumping all beef production into one unified group when we know that's not the case. Most people have no idea that most water that's used for grazing systems is green water. It's not used at all. We know that grazing in a certain way can actually be beneficial, or that most grazing happens on marginal land, right? There's a lot of nuance there. And that different things that you do on farm or on ranch contributes to significantly different environmental outcomes. How you manage your grazing, where you source your feed, where you're located in the world, your precipitation, all of those things are going to look very different from an environmental perspective. So just those little sound bites don't give us any information in that regard. The second, and kind of in the same vein, is addressing some of the challenges we have in soil carbon science. So again, with breaking down generalizations, statements like, grazing cattle is carbon negative. Unfortunately, that's not a universal truth. We still have a long way to go in soil carbon science and grazing. And we're just starting to scratch the surface, understanding what we're measuring. But in some systems, grazing might actually be a carbon negative endeavor. But over what time scale, at what depth, in what regions of the world? And we don't have those answers right now. So being patient with us, standing with us with some of that nuance, and trying to realize that we still have a long way to go will be really important. The last one that I think is important to mention is building coalitions. There's an entire sector of scientists, of advocates, of farmers, ranchers, a bunch of people talking about this, people who are in this space. It's getting more and more crowded every day. But we all approach it from a different perspective, right? Many people think of it just in terms of land use change, or in terms of emission or nutrition. And we're all kind of talking at each other, not to each other. But we all want the same outcome, right? We want healthier food from better landscapes that are addressing climate change. So I think we need to learn how to talk to each other. We need to bridge those coalitions. We can't just see challenges like the Impossible Burger and address it with a knee-jerk reaction of opposition. I think it's going to serve us in the long run to talk to these people, talk to them about what you guys are doing on the land, the outcomes that you're getting, what we're seeing in the science, nuancing that conversation and seeing where we can build those bridges and move forward. If we look at tactics that the industrial agriculture industry has used, people like Monsanto or the tobacco industry, if we want to distinguish ourselves from them, we can't use the same scare tactics. We need to talk real talk. So the second thing Jason asked me to talk about, or all of us to talk about, was a snapshot of our work. And Jason and I, just this time last year, published a paper together, and he described it a little bit, but essentially it was a life cycle analysis, which is a greenhouse gas emissions study of beef in this case. And I'll try to explain the best I can here with just this one graph. I could talk for just maybe an hour on this work, but your ears might bleed, so I'll do the best I can. So we built a life cycle analysis, but really it was different in three key ways. The first is that most life cycle analyses for beef, they utilize continuous grazing for all grass-fed, right? There's, again, back to that nuance piece, there's no distinguishing of different grazing management practices. So in this way, they're kind of pitting worst case scenario of grazing against feedlot, and that is what we've seen among almost all LCAs. So the first different thing that we did was that we were trying to quantify emissions from an adaptive multi-paddock system. We did this using, like Jason said, real data. We had on-farm data for this. So if you look in this graph, the light green bar is our adaptive multi-paddock grazing emissions compared to the feedlot system in the darker green bar. And you'll notice that the adaptive multi-paddock system did have higher emissions compared to the feedlot. And I won't talk exactly about why that is here. I'd love, hint, hint, to get some questions about it. But this is pretty common, right? Almost all grazing systems have higher emissions than feedlot, and I can talk about some reasons why. But if we were to compare AMP emissions, so adaptive multi-paddock grazing emissions, to continuous grazing emissions, these were 45% lower. So we cut continuous grazing emissions in half just by using a different type of grazing management here. Why? Why would that be the case? The first thing is that these animals had a shorter finishing time. We were managing for really fast rotations, high stocking density, but again, it was adaptive. And we did have really high forage quality, right? We're in a temperate area, we have high precipitation, and it didn't take long to finish these cattle, as long to finish as an arid area or as in a continuously grazed system. And the last thing is that we didn't apply any fertilizers. Nitrous oxide coming from the application of nitrogen fertilizer is a really potent greenhouse gas emission. And in a lot of these LCAs, they model an application of fertilizer to pasture. We don't have to do that, and we didn't in this case, and it significantly contributed to lower emissions in this grazing system. Second big thing we did was we measured soil carbon. And this had never been done and put into a greenhouse gas model before in beef. So before I even got to Michigan State, Jason and his team had started measuring soil carbon sequestration on the Lake City Ag Bio Research Center station. What did we see? In this exact same system where we were AMP grazing, we had a soil carbon sequestration rate of 3.5 tons of carbon per hectare per year. That, I'll use the same word, is non-trivial. A lot of the sequestration rates that we see thrown around in the literature that had come before this was along the lines of 0.4 to a half a ton of carbon per hectare per year. That's low. We were so much higher here. So what happens when we turn that soil carbon sequestration into greenhouse gas emissions language? We turned this net positive emission, so this lime green bar, 9.62 kilograms of CO2 equivalents per kilogram of carcass weight, into a carbon sink. So we see the difference there. That's 170% reduction rate in greenhouse gas emissions just by using AMP grazing. I got a question from this earlier, so I'll go ahead and address it. Notice that the feedlot emissions went up by just a little bit. That's because I also accounted for the carbon emissions coming from soil erosion, so we accounted for the soil erosion induced CO2 emissions from the intensive cropping system from which our feed was coming from for the feedlot. So it didn't contribute to much, but it's just a tiny increase on the feedlot side, and obviously there was no carbon sequestration opportunity there. Last thing that I was asked to address is something that gives me a lot of hope. You know, these are big challenges, big data, but what are we going to do moving forward? And one thing that gives me a lot of hope is just seeing you guys in this room. People at this conference, people here who have been huge thought leaders and big inspirations to me. You know, Wendy Millett, Lauren Poncha, Joe Morris, Will Harris, who's my all-time favorite. You guys are the boots on the ground. What I do, what us scientists do, would be moot if you guys were not there to apply it. So I can't thank you guys enough. But what really gives me hope on the science side? This is what I do for a living. This is what gives me passion. And this is a hard slide for me to make, honestly, because we have a lot of challenges here, but where is the light? And really where I garner my inspiration from is science that is not siloed, science that thinks in wholes in the way that nature does. This intersection of animal and environment and people, things that really bring everything together, it does not happen often in the science community. And I think maybe that's a result of the land grant complex or what's normally been funded, but the result is that we just don't have much of this science, honestly. People like Jason Roundtree, Cindy, these are pioneers in this field, and I really owe what I do to them. And Jason took a huge opportunity on me doing this kind of thing because I came from cell biology and economics and somehow wound up doing work like this. So yeah, what we do, it has to incorporate these three realms, right? Environment, animal, social. Really, none of those things happens in a vacuum. We have to be thinking about this in terms of the whole. And I'll just make a call here to say that this research is chronically underfunded. We are suffering from a funding shortage. We need to do some ground truthing with regenerative grazing practices and its impacts on soil carbon, its impacts on emissions in different areas, with different precipitation, with different levels of management. And we need science to do this. We need evidence-based research to be able to wield that sword and really put our power behind regenerative agriculture. We cannot do that without research funding. And coming from a personal experience, I'm at UC Berkeley now, trying to do research, and it's a struggle. So I hope that call is loud and clear for those of you who are interested in R&D funding. We definitely need it. That's it from me.